Educational technology is inherently the study of making technology work in lockstep with the learning environment. We compare educational technology to a fish tank, surrounded by clear glass in order to better allow for the active examining of a subject in detail in order to discover new information. Poor design of a fish tank, much like a poor grasp and study of educational technology, leads to a toxic environment. Imagine a fish tank, sparkling and pristine, but without the needed pieces in preparation. Crystal clear water would soon give way to murky, algae-filled muck. The fish would struggle to survive, much less thrive. This is what happens when, apart from careful study and preparation, technology is haphazardly introduced into a learning environment. The teacher, students, administrators, parents, and all involved fall victim to the cloudy, choking water. As you'd consider a manual about where to begin outfitting your tank, so too educational technology first turns to instructional design, to see how best to begin the teaching-learning process. Chapman and Cantrell write, "What instructional design has everything to do with is translating pedagogical research and practice into instructional curriculum specifically crafted to produce desired learning outcomes." With the proliferation of online instruction, however, researchers are questioning whether traditional concepts of instructional design are applicable. Most instructional design models hold the teacher as the source of information, imparting content to students. Modern teaching and learning methods, however, thrust the teacher into more of a facilitator role, as evidenced once again by Melinda and Januszewski's 2008 definition describing educational technology as the study of facilitating learning. Students working together, building their understanding through collective research and ensuing dialogue, don't require the same rigid design as lessons past, but rather the more organic cultivation of a learning environment. What does that look like? Sims suggests the alternative is for design to focus on learning outcomes and aligned assessments, with learning activities that are based on resolving a problem or issue, making learning relevant to the individual learner, so situational differences and solutions can be used to debate and evolve accepted practices. This concept has spawned game-based learning, in which individuals learn subject matter content through solving a series of problems or challenges embedded within the game. There are multiple strategies or solutions to reach the desired end, but all involve critical thinking and decision-making. Instructional design is the manual that informs educational technology. Going back to our fish tank, most manuals recommend having a solid base on which to add components to your tank, most often gravel. The study of educational technology, likewise, is anchored on the solid foundation of educational psychology and learning theory, the underlying assumptions regarding how people acquire knowledge. Just as gravel is made up of different types of rocks, so too educational technology is made up of various learning theories. Early learning theory ascribed to the concept of behaviorism, popularized most famously by Watson, Pavlov, and B.F. Skinner. The general idea was that given certain rewards and punishments, subjects could be trained to respond predictably to specific stimuli, a concept now seen embedded in educational games. Researchers, recognizing that humans were more than just inputs and outputs, later turned their favor to a theory called constructivism, which claimed proponents including Dewey, Vygotsky, and Piaget. This theory focused on what internal and external factors contributed to an individual acquiring and assimilating knowledge. Tony Bates in 2014 wrote, "The concurrence of both constructivist approaches to learning and the development of the internet has led to the development of a particular form of constructivist teaching, what Harris-Sim now calls online collaborative learning theory, or OCL, a model of learning in which students are encouraged and supported to work together to create knowledge, to invent, to explore ways to innovate, and by so doing to seek the conceptual knowledge needed to solve problems, rather than recite what they think is the right answer." Bates goes on to describe a new theory of learning called connectivism, rooted in the relatively recent deployment of massive open online courses, or MOOCs. He cites Downs, one of the leading proponents of this theory, who has laid out some basic design principles for constructivist courses, or MOOCs, such as learner autonomy, openness, diversity, and interactivity. In an even more facilitative role, Bates states, "The main purpose of a teacher appears to be providing the initial learning environment and context that brings learners together, and to help learners construct their own personal learning environments, to enable them to connect to successful networks, with the assumption that learning will automatically occur as a result, through exposure to the flow of information and the individual's autonomous reflection on its meaning." There's no need for formal institutions to support this kind of learning, especially since such learning often depends heavily on social media, readily available to all participants. Though the theories and their concepts continue to evolve, they nevertheless give a solid base to the field of educational technology. In addition to a solid foundation, perhaps one of the most crucial components of the fish tank is a filter. Without this, no matter how well you start assembling the tank, the water won't stay pure. Ethics are the filter for educational technology. Without ethics, the field becomes irreversibly tainted. As Yeaman 2005 notes, many factors have influenced and will continue to affect professional ethics for technology. A few are relatively solid and persist, such as traditions, laws, institutional rules, and professional licensing. Others are much more transitory, such as economic pressures, government support, and the cycle of successful inventions becoming successful products, which then fall into obsolescence as new inventions come around. We see the persistence of ethics on a large scale with the fight to protect musicians, authors, artists, and others from digital piracy and copyright infringement carrying over from the early days of media. We also see the transitory nature of ethics in the procurement of, financing, and rapid market escalation of digital instructional materials and assessments. Ethical shortcuts and compromises usually lead to negative headlines and failed projects. At the level of the individual teacher, there are two major areas of ethics: professional practice and digital equity, including how they use technology for communication, use of student data, and the digital citizenship they demonstrate in the acquiring of materials and information. Secondly, as educators, the idea of digital equity, equal access to digital tools and content, should encourage the pursuit of social justice within educational technology. In this age of online learning, flipped classrooms, discussion boards, and digital assessments, it is unethical not to fight for equal learning opportunities for all students, regardless of socioeconomic status. In 2001, Latimer cautioned against this divide, writing, "Educators are creating a larger social gap between the rich and the poor, chiefly within technology now, despite the fact that they justify the inequities in funding, technology, and programs. Injustice and inequalities clearly exist in our schools and within technology, and these discrepancies do threaten justice and make it an impossibility so long as these disparities are perceived as being fair and right. As educators and as proponents of educational technology, we have an ethical imperative to address this important gap. When we do, we'll have a clearer tank to look through as we study the implications of technology and education for all students."
After the major parts of the fish tank are assembled, it is time to introduce the fish and make sure that they are the best swimmers they can be. To that end, it is important for the fish to understand the process behind swimming, just as it is important to understand the technological processes behind educational technology. There are a wide variety of processes within the field of educational technology. Although its origins are unclear, the ADDIE model of analysis, design, development, implementation, and evaluation is considered one of the major processes that comprise the generic instructional systems development process. The ADDIE model is not the only technological process utilized in the field of educational technology. Others prefer to use a model similar to the design process model. The Australian state of New South Wales recommends a technology process centered around designing and producing solutions for authentic needs and opportunities, specifically exploring and identifying the task, followed by generating and developing ideas, and finally producing solutions. There are many other technological processes, but they appear to follow a basic framework of inquiry and development. The fish is now ready to swim in the tank and to be creative and utilize its environment. Educational technology can be a solution to a perceived lack of creativity. Scardamaldia and Bradier suggest that there needs to be a shift in the locus of constructing knowledge from the individual to collective construction. They argue that education needs to be refashioned in a fundamental way so that students are initiated into a knowledge-creating culture and see themselves as a part of a global effort to advance knowledge. According to McLaughlin and Lee, web technologies can play a crucial role in fostering knowledge building in communities or networks and aid in the preeminence of content creation over content consumption and the collaborative production of knowledge. The key, according to Preble, is inspiring students to become curious, engaged, and interested in the world around them and within them. Using technology effectively is a large responsibility for teachers, and when used correctly, educational technology has been used to help in improving and enhancing student learning. Some of these gains can be difficult to measure, however, as many states are not tracking the outcomes for the expenditures related to educational technology. Additionally, without proper training, many schools revert to the traditional uses of technology as a passive system rather than an active one. Solutions to this problem include providing those responsible for implementing educational technology with the resources and incentives to utilize technology effectively. When used properly, technology can support student collaboration on creating new knowledge. Technology can also clarify and stimulate thought through transforming words into pictures. A fish cannot swim without water, much like learning cannot take place without a solid foundation. It is important for educators to make sure that they are involving and enabling children to take part in the decision-making and acknowledging their actions. One of the keys to facilitation is to be an active listener, making sure that students understand what is expected of them, and to contribute. Too often, participation is understood as the practice of educators listening to or consulting children and allowing their voices to be heard. Facilitation breeds learning, and learning effective learning outcomes are the goal of every educator. Learning, in regards to educational technology, can be defined as a knowledge-building activity to build certain core 21st century skills, such as collaboration, digital literacy, critical thinking, and problem-solving. According to Kangas, learning that is enhanced with technology can provide students with opportunities to examine concepts that can't be presented in class due to concerns related to safety or material availability. Kangas goes on to suggest that online opportunities can provide for such engaging experiences as discovery learning, multiple representations, deep analogies, and challenge-based learning. These are not the only benefits of educational technology as related to its influence on learning. Learning can happen from various environments and contexts, including when online surfing the internet. Educational technology makes more varied types of learning more accessible to a larger proportion of the population. Water in a fish tank, just like learning in the classroom, cannot go unregulated. In water, a heater is needed to keep the temperature at an appropriate level for the fish. With educational technology, there are appropriate steps that need to be taken in order to ensure proper management. Ideas and management strategies differ. Some see acceptable management as making education more cost-effective while improving student learning. The other side of management is within the classroom. Illen and Illen suggest that educational technology used properly can aid teachers in their classroom management, but they require training sessions and in-service opportunities as well as modeling to show appropriate outcomes. Management in the classroom can also be hindered by technology. Illen et al. Suggest, especially if teachers do not trust students to use technology appropriately. For students to be successful, they must be provided appropriate stimuli, just as fish in tank enjoy a well-placed castle or scuba diver, and their swimming skills improve as a result. Student performance can increase as a result of educational technology. According to a 2013 survey conducted by Deveskiem, Stark, and Watroba, students favor the use of educational technology in the classroom, reporting specifically that laptops can improve note-taking information gathering in class. A 2016 Speak Up survey indicates that increased student performance with educational technology is a growing trend, with 54% of principals surveyed reporting positive learning outcomes as a result of the use of the implementation of digital content. With strong implementation procedures and proper supports for teachers, educational technology has the capability to increase student performance and improve student outcomes.
Now let's talk about the professional development portion of the fish tank. When you get a fish tank, you have to learn where it could go in the context of a larger room you are placing it in. Think about if you place a fish tank as a teacher in your classroom. If you are placing it on your desk, it may hinder the productivity of the work that you must do, like grading or working with an individual student. If you place it on the podium, it could be a distraction when lecturing to your students due to blocking the line of sight from students to the content being displayed. As some of us may recall, putting the fish tank on the table space by the window was the best spot because it allowed the fish to have sunlight if needed, it did not distract from the classroom activities, and it demonstrated responsibility of caring for a living animal. Think of the fish tank being placed appropriately in the classroom as a piece of educational technology being integrated in a particular educational environment. Before even thinking about placement of the educational technology, our sources will tell you to not start with the technology. Instead, think about the various tasks or classroom activities you may want to do in your course first. After all, it's not about using the coolest piece of technology in the classroom for the sake of just using it. To figure out a blueprint of how one could more effectively integrate technology, think of these four components of learning: active engagement, participation in groups, frequent interaction and feedback, and connection to real-world experts. Along with the overall placement of the technology integration in the larger room, there's another portion of professional development that we would like to call the fish food. From the castle classroom activities to the swimming assessment of your students, it's important to understand what technological resources are available to you as an instructor, educator, and/or administrator. There are several ways we can define technological resources. For example, one definition describes technological resources as systems and tools required to effectively produce and create a product or service, while another definition states technological resources include their intellectual property, their copyrights and patents, and their experiences and skills. Do you consider yourself an educator that creates a product or service and uses tools to do such creation? Such technological resources fall into this broad category of professional development because technological resources represents not only the tools that you use, but the systems you create to make sure you use the educational technology effectively. Do you have professionals or offices at the institutions you work for that may help you create the systems and select the right tools for your classroom activities? If they are there, Are they asking the right questions, such as how much energy are you willing to put into creating an effective classroom activity with X technology you're using? Or who is your intended audience for this classroom activity? These questions are very important to process both by yourself and your peers around you. Throughout this presentation, we have talked about the castles and plants that are used to challenge and support our students through both the educational technology and the instruction we give them. The final task of any educational process includes assessment and evaluation. In this section, we will finish the educational technology analysis of the definition by discussing the evaluation and performance improvement that educational technology may allow. We will also discuss how future research can also progress the process in adequately using educational technology appropriately to best provide effective instruction. So let's think of the fish tank analogy one last time. How do we effectively know that the fish tank has all the proper conditions necessary for the fish to survive? If the fish are not belly up, but seem they are not swimming as well as they could, we evaluate what might be happening that they are not swimming at capacity. Then, we change the conditions of the tank to potentially help them swim better. This analogy can tie directly into how we evaluate the educational technology we use and essentially evaluate how well our students perform considering the use of the educational technology. So what do we mean by evaluation in terms of educational technology's definition? If you are a part of an educational institution that carefully integrates technology in educational activities, it can be recommended for the institution to set goals, prepare contrast data from before and after technology use, collect data, and analyze the results related to each goal you set for integrating the technology. Requiring such steps for any educational technology integration will be helpful in avoiding the false tech candy situation where the cool flashy software fails because it was not the appropriate technology for the type of educational activity that was being done. Along with evaluating educational technology as a whole, you also have the opportunity to evaluate performance improvement. In the context of educational technology, performance improvements asks the question, did the assistance improve the performance of people, groups, or organizations by understanding where gaps exist and identifying the best solutions for them? If there was any impact, was this impact due to the educational technology that was provided? Last but certainly not least, we are now going to focus on future research. As a group, we think future research is like the pH test strip, to test and see if the water has the right balance to ensure the fish are surviving. Just as testing the water with a pH strip sounds really scientific, providing future research in educational technology is also pretty scientific. Just as evaluating performance improvement and how the educational technology supported such performance improvements are necessary, doing such evaluations in a scientific approach will validate and enhance teaching and learning to new levels. When looking at future research in educational technology, there are diverse ranges of topics that one can explore that fits the needs of different challenges. For example, research may look different from those looking at instructional challenges through a constructivist lens versus a researcher that may be looking at a challenge from a behaviorist lens. Although it is not about which lens is right and wrong, it is whether or not there is a question that is finding the right solution for a situation that may be happening to you or a colleague that you know. Before we finish the future research portion of this presentation, here are a few areas that are being researched in educational technology: blending formal and informal learning, improving digital literacy skills, personalized learning, teaching complex thinking, competing models of educations like MOOCs, and identifying and rewarding great teaching.
Encompassing a wide range of components, from the manual of instruction design to the filter of ethics, the fish food of technological resources, the heater of management, the foundation of educational psychology, and the pH test of assessment and evaluation. Educational technology provides the water of a learning environment, where, just as the fish swim in the water, so too teachers and students can use the technology to create meaning in the teaching-learning process, enhancing their overall performance. When all of these parts function together and are integrated appropriately, educational technology results in a healthy and productive place of learning.